Hello and welcome to the treat video. If you are yet to watch my previous video about the magic trick that I performed for the 24-hour maths magic show, then I highly recommend you go and do that. There's a link in the description below. But this video is my treat, which was going to be all about groups and isomorphisms. First, we need to know what a group actually is. In maths, we say that a group is a set G with a binary operation, usually denoted by a little circle, which is governed by some rules which we call axioms. The first axiom is closure, which says that anything you do in the group stays in the group. Then you have associativity, which says that you could put brackets wherever you like. So you could do 2 times 3 times 5 if we looked at multiplication, and you can do 2 times 3 first, which is 6, times 5, 30, or you could do 3 times 5, which is 15, times 2, which is 30. Again, it doesn't change the answer. The third law is the identity law, which says that there's some element in your group which, when you operate it on another element, you get that element back, which is basically what 1 does in multiplication, because 1 times whatever number you like is whatever number that was. And finally, we have the inverse law, which says that for every element in your group, there's some other element in the same group where when you operate them together, you get 1, or the identity, back. Now, we can look at the group of unit integers, which a unit is just an element that has an inverse, okay? And so this group contains 1, because 1 times 1 is 1, minus 1, because minus 1 times minus 1 is 1, and that's it. Because no other element in the integers has an inverse in the same set. Now we can make a multiplication table for this group, as you can see here. Okay, and we can fill that in. So 1 times 1 is 1, 1 times minus 1 is minus 1, and so on. Okay, and so that's all well and good. Great thing about groups is we can also use them to describe symmetries of shapes. So if we looked at a square, for example, we can define the identity symmetry, which I will call E, okay, as just doing nothing. There, that's a symmetry. Okay, and we can also define a reflection in the vertical axis, which I will call S for symmetry. Okay, and that, like that, that's a symmetry because it's still the same, it still looks the same. Okay, there are other symmetries of a square, but we won't go into those today. And we can make a multiplication table of this group, okay, which you can see here, and you can check the axioms yourself, but they all hold up. Now, if you look carefully, you might, firstly we need to think, how are we operating? Well, when we operate with a symmetry, it just means doing one and then the other. Okay, so you could do E operate S, which is doing E first, okay, so nothing, and then a reflection. Well, that's the same as doing a reflection, okay? You could just ignore the E, okay? And so we can use this rule of the operation and fill it in, okay? So we could do that. But if you look carefully, well, then you might notice some similarities between these two groups. In fact, if you change E to 1 and S to minus 1, well, then these groups are the same, and that means they're isomorphic to each other. Now, this doesn't mean that they are the same group, rather they share the same structure. Okay, and isomorphisms are brilliant because you can use facts about one to prove facts about the other. If we look at these two groups, okay, we know that 1 times 1 is 1. That's definitely true. We know that. Okay, so if we map that through the isomorphism, then that becomes E operate, which is times, E equals E. And that's true, we can check that. Now, of course, this is fairly simple, okay, but that's because we're working on quite a small scale. You can scale this up to larger groups and the same rules still apply with isomorphisms. So an example of a real life isomorphism that you probably all do without knowing is counting. When you learn to count, you might have learned to count on your fingers. And what you're doing there is you're actually forming a bijection, which is another word for, which is the word we use for the function between the two groups. You're forming a bijection or an isomorphism between the set of your fingers and the numbers 1 to 10. Okay, and this is brilliant because it allows maths to happen, basically, and I think that this is great. And that's all I have to say on isomorphisms. I love them because it's like random thing here, random thing here. Oh look, they're connected, and I think that's brilliant. But I hope you enjoyed this video, and thanks for watching. Goodbye!